Okay, we'll look at some of the homework problems in section 12.4, which dealt with similar triangles and other similar figures. In number 1, we want to determine whether the following pairs of triangles are similar. If they are similar, explain why and find the scale factor of the triangles that are similar. The figures are not drawn to scale, so keep that in mind. So here we got two triangles, ABC and DEF. We want to find out if they're similar triangles. In this case, they are, because if you look at angle B and angle E, they're congruent, and also angle C and angle F have the same angle measures, they're congruent. And there is a theorem that says if you have two angles of one triangle and they're congruent respectively to two angles of another triangle, then those triangles are going to be similar. And in this case, it's going to be the angle-angle similarity for triangles here. So we have to choose the one that says angle-angle similarities here. So triangle ABC is similar to triangle DEF by the AA similarity for triangles theorem. Now we want to find the scale factor, and we're going to write this in the form of a fraction. Well, the scale factor is going to be this, 4 to 9. So as a fraction will be 4/9. Okay, part 2. I want to find out if these two triangles are similar. Okay, now let's look at this. Angle B is congruent to angle D. Also, angle A is congruent to angle E. So again, we have an angle-angle similarity and angle-angle similarity. So that means here we have to use the angle, we have to select the one that says angle-angle similarity. Okay, now we want the scale factor for each one of these. So in this case here, if you look at this, AB is proportional to DE. The scale is 2 to 4, which is in this case 1/2. Or you could look at this, BC and AD are proportional. So that scale factor will have to be 1 to 2 as well. Okay. Now here's part 3 of number 1. Okay. So we want to prove or show that these two triangles are similar, if at all possible. Okay, now in this case here, angle B and angle C are congruent to each other. Now, you might not be able to see this, but angle A, we can use this one. Angle A is congruent to itself, because angle A is the common angle in triangle ABC and triangle ACD. Okay, so here we can use the AA similarity for triangles. And then we want to find the scale factor for this one. Now, let's be careful here, because this one for ACD, you have to add 3 plus 1, which will give you 4, over, and then ABE. AB has a length of 3. So the scale factor would be 4 over 3. The 4 came from, for ACD, you have to add the lengths of these two, AB and BC, together to get AC, 3 plus 1, which is 4. And keep in mind, BC, of course, is not a side of that particular triangle. Okay, and part 4 of number 1. Okay, so here we want to select the correct choice. Now, by looking at this, AB is proportional to BD. And also, BE is proportional to BC. And for the reason that vertical angles are congruent, I can say that angle ABE is congruent to angle CBD. Okay, so here we have a side angle side similarity and a side angle side similarity. So here we're going to choose this answer choice. That triangle ABE is congruent to is similar to triangle DBC by the side angle side similarity. And we want the scale factor here. Okay, let's work with these two, AB and DB. 4/6, which is going to reduce to 2/3. So that scale factor will be 2/3. Okay. All right, on to problem number 2. In the following figures, find the measure of the sides marked X. Note that the figures are not drawn to scale. So here we want to look at part A, figure A. Okay, now, here we got a line that's intersecting two sides of this triangle, meaning they intersect proportionally. In this case here, AB is going to be proportional to BD, and AC is proportional to CE. So in this case here, if I want to write this as a proportion, AB has a length of 3, and I'll just go ahead and write this out. AB is proportional to BD, and AC is proportional to CE. So in this case here, AB has a length of 3. BD also has a length of 3, so that's 3/3 is equal to, now this is X, AC is going to be the length X over CE, which is 8. So here we're trying to find out what X is. If you cross multiply 3 times X, you're going to get 3X equals to 3 times 8, that's 24. So 3X is equal to 24, and divide by 3, you're going to get X is equal to 8. So for part A, X is equal to 8. Okay, now part B looks like this. All right, now we got two similar triangles. Triangle ABC is similar to triangle EDF. Now, we want to use the ones that are proportional. Here, BC is going to be proportional to DF. And we want AB to be proportional to ED. Okay, because I know what the length of AB is and what D is. Those are proportional. Okay, BD, sorry, this should be BC. BC has a length, is what we're trying to find, that's X. It's proportional to DF, that's 9. That's equal to AB has a length of 3, and ED has a length of 7. Okay, so now we can do cross multiplying. 7 times X, that's 7X, equals to 9 times 3, that's 27. So 7X is equal to 27, and if we divide by 7, we're going to leave this as 27/7 for X, because they want us to type in the answer as a simplified fraction. So here this will be 27/7 for X. Okay, so whatever the directions say here, you want to do what they say. Just type it as a simplified fraction and not change this to a mixed number. Okay. All right, problem number 3 is this. This is an application for similar figures. How high is a tree that casts a 27-foot shadow at the same time a 9-foot post casts a shadow which is 14 feet long? So here's how we're going to do this. Let's say we have a tree. We want to find out what the height of that tree is. That's your X. It casts a shadow that is 27 feet long. Okay, so from the tip of this tree, okay, you can see that's going to be one triangle. And at the same time, you have a 9-foot post. Here's a post that's 9 feet long, casting a shadow that's 14 feet long. Okay. This is another similar triangle. Assuming that these two triangles are similar, we can find out the height of that tree. Okay, now the proportion I'm going to set up is going to be the height of the tree to the shadow. It's going to be equivalent to the height of that post to that shadow, to its shadow. So we'll have x over 27. That's equal to 9 over 14. Now there are many ways that you can set up a proportion like this way. I'm just doing the height of the tree to its shadow, to the length of the shadow, or height of the object to the length of its respective shadow. Now, let's go ahead and simplify this. Cross multiply, you're going to get 14 times x, or 14x, equaling to 27 times 9. Okay, and if you have a calculator, you can do 27 times 9, which is 243. So 14x is equal to 243. And then we're going to divide both sides by 14. Okay. Okay, and here I'm going to get 17.4. Had to think about that for a moment. Okay, and they just say round to the nearest tenth if necessary. So in this case, if you get, when you do this on the calculator, you'll get 17.35714,286. But to the nearest tenth, it'll be 17.4. So the height of that tree is approximately 17.4 feet. Okay, so that's how you'll do this particular problem. Okay, now here's another example of a proportion problem with triangles. Find the distance, which is going to be the length d, that's this length, across the river. Assume that the triangles are similar and the ratio of d to 150 is the same as the ratio of 200 feet to 400 feet. Well, that should be easy right there because they tell you what the ratios are. So here, of d to 150, that's going to be d over 150, if you write that as a fraction. That's equal to the ratio of 200 feet to 400 feet. That's 200 over 40. 200 feet to 40 feet is 200 over 40. So there's your proportion right there that we can easily find out what d is. Cross multiply, 40 times d is 40d. 150 times 200, well, 15 times 2 is 30 with 3 zeros. So that'd be 30,000. 40d is equal to 30,000. And then you're going to divide both sides by 40 to find out what d is. So d is equal to, so we'll do 30,000 divided by 40. That'll give you 750. So the distance across the river, which is your D, so the distance across the river is 750 feet. So that's what D is. The distance across the river, 750 feet. And that should assist you with some of the homework problems in section 12.4.